Hello and welcome to another video. In this one, we're going to be talking about try except or exception handling. We're specifically going to be looking at Python, but this advice also applies to any other language which has this sort of exception handling flow as well. Without further ado, let's jump into it. Okay, so we're going to be talking about try except statements today, and the syntax for these is kind of straightforward, but there's a lot of combinations that can happen here. So it starts, and it always has to have the try statement, or the try block, and this is going to include code, which may raise an exception. So that'll be here. Then it has either any number of except blocks or a finally block. So if we do, except exception, this is code that runs when an exception occurs. Like so, and you can have multiples of these, so you may have like some other type here, so let's say type error, for example, and you could also have an except block which has no type here at all. And I did another video on this, so I will try and remember and link that in the description. This catches all exceptions, including exceptions that should terminate the process, and so I generally recommend against doing this. And if you absolutely need to, you can catch base exception instead, which catches all exceptions, including those that should exit the process. But it's a little bit more explicit that you're intentionally trying to do this and not just, putting except blank except here. You can also capture exceptions. So if you need to assign them to a variable, you can use as e, and you can also catch multiple types within a single except block. So when I'd catch type error and assertion error, you can parenthesize these. You can also do that with this syntax as well, just replacing the exception type here with a tuple of exception types. Okay, so that's the except block. Then there is an optional finally block. And again, these blocks, except blocks and finally blocks, are both optional, but you have to have at least one of them. And a finally block is code that will always run independent of whether the code succeeds or raises an exception. Always runs independent of success. And then the last part of a try is the else block, and this is code that only runs if successful. And again, this is optional as well. So a lot of optional parts. The try part is the only required part, and one of these must be there. Can you actually have a try else without anything else? I wonder. Try else. No, you can't. Okay, so you have to have at least one except or finally. It wouldn't really make sense if you had try else. It would just be, you might as well just write the code at that point. Cool. So now that we understand the structure of a try block, let's talk about some of the best practices that I like to enforce on a try block. And the first is the amount of code that you'll put in your try block. My recommendation here is to minimize this code as much as possible, ideally only being one statement, one assignment, one line, and nothing more than that. Narrow it down to just the code that can raise a particular exception. And the reason for this is it's really easy to accidentally introduce more code in there that causes other exceptions for other reasons, which might accidentally hide a programming error instead of your actual error handling code. For instance, if you ran a HTTP request that may produce an error back, but then you do some data management after the HTTP request returns, you probably don't need to have that in the try block, since it's not something that you expect an error to occur in it. So you might have something like response equals get thing or whatever, and then data equals response.json, etc. And then data foo equals r, or I don't know. You might do some additional massaging of the data there. And my recommendation is to take this code, which shouldn't be raising exceptions, and move that out of the actual try block and into some other place. I usually put it into the else block, where this will only run if this piece of code is successful. That way, you could also eliminate the else and dedent this if you make sure that you're not allowing exceptions to pass through, but I usually like to be a little bit more explicit and use the else block there. The next part of the best practices here is to limit the exceptions that you catch here to only ones that you expect. So usually, this goes back to not using a blank except, and additionally not using just, normal exception here. And the reason is there's a lot of types in Python that are typos or caused by programming errors that you don't want to capture as user errors. You want to make sure that those things are separate. Like for instance, if I had typoed this and there was a get thing function up here, this is going to raise an exception in Python. If you have a name, you're going to get a name error, and unfortunately name error is a subclass of exception, and so it would pass through to this block. So my recommendation is to narrow the types that you're catching to only ones that you expect to have here. And so that can be like, I don't know, urlib.error.http error, for example, if that's one of the types that you expect to catch here, and not to catch, generic exception. And then you can handle this specifically. Another best practice is re-raising exceptions. If there's something that you may need to do, like logging or whatever, and then you want to continue to bubble that exception up, you'll write, let's say that we do actually want to catch all exceptions and do some amount of logging here. You could do, log thing e, and then you'll use the raise statement. And this raise statement takes no arguments at all, and it's just going to continue the bubbling of that exception. So you can do whatever logging or handling here, but you won't affect the actual error state of this. And some caller that knows how to handle that better will be able to take that exception and handle it. And so that's raise. A common mistake that I see is to do raise e. This actually introduces another set of stack frames and isn't what you want. Generally, you generally want to preserve the original error trace from this here. Now in Python 3 you'll get stacked traces, so it will preserve it in some ways, but yeah, it's one easier and better to just choose a normal blank raise statement. And if you don't need to handle anything, so let's say you're not logging anything here, you should be able to just remove this block entirely. Because this, except e raise, this is a no-op. It doesn't do anything here. So you can usually remove this if you don't have any other special handling. And then the last bit is finally blocks, and this is mostly for doing cleanup code. If you have some resources that you acquire before your try block, and they should get cleaned up by the end of this, you can put them in a finally block, or you can move that to a context manager to do. To use a with statement instead. But anyway, that's kind of my best practices for using the try statement and also how it works. So to summarize, limit as little code as possible inside of the try block and use as specific exception types as possible in this, and use just blank raise if you need to re-raise stuff out. Anyway, hopefully this was interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.